Hello everyone, welcome back. And today we are will be talking about a topic called voting classifier. So in machine learning models, there are models. They come in many forms, like decision tree, logistic regression, support vector machine, and more. But what if we could combine them to improve accuracy? Here's enter the voting classifier. Now, what is voting classifier? So it's a ensemble learning technique where multiple individual models they votes on the final prediction. It's based on the idea that combining multiple models can reduce error, improve performance, and create more robust system. Think of it like a group discussion. Each model casts its vote, and the majority decision wins. In classification problem, each model works together to predict the class of each instance, and the final output can be determined in two ways, right? So this is the training set. This is the classification models, and they predict the prediction happen from each model, and after the voting, the final prediction take place. So there are the final output can be determined in two ways, and let's talk about hard voting and soft voting. So in hard voting, each individual classifier gives its prediction class label, and the class that received the majority of vote is selected as the final prediction. And with the soft voting, the classifier gives probability for each class, and the class with the highest average probability is selected. And this method is more nuanced and can often provide better performance. So let's dive into the code and see how we can implement the voting classifier in Python using breast cancer dataset. This dataset has features that helps predict whether a tumor is misaligned or benign. benign. So we'll import our necessary libraries for this, and then we'll load the data of the dataset. Next, we split the data into train and test set, and then we'll define individual models, right? Decision tree classifier, gain neighbor classifier, logistic regression, and then we'll create a voting classifier, and we are voting type is hard. Fitting the classifier here, right? And now let's do some prediction, and then we'll evaluate. So our final score comes as 97, and we can see now let's compare the performance of individual classifier. We'll train and evaluate each one separately and then see how they perform when combining into voting classifier. So let me train the individual model. Here we are making the prediction and evaluating, and we run this. So as you can see, we train each model separately and evaluated their performance. And the results here we got, if the decision tree accuracy is 0.9, the KNN is 98, and the logistic regression accuracy is 0.98, and the voting classifier is 97. So as you can see, the voting classifier achieves a slight higher accuracy than uh, almost from the other, right? And this demonstrates how combining models they can lead to better performance by leveraging their complementary strength. Now let's also go through the pros and cons of the voting classifier. So the main advantage here, improved accuracy by combining the strength of multiple models. The voting classifiers often performs better than the individual models. It also works well with the combination of classifier, whether simple or complex. And the last one, it's reduce the overfitting. So using multiple models reduce the risk of overfitting that may occur with a simple or complex model. Now the disadvantage is competition cost. More model means more competition time, and which can be a problem for large data sets. The next is interpretability, means since it's combined multiple models, it's hard to interpret the final prediction compared to this single model. And to summarize, the voting classifier is a powerful ensemble method that combines multiple classifiers to improve accuracy. Whether using hard voting or soft voting, it is a great tool to enhance your model performance. Yep, that's it. Thank you for watching. See you in the next one.